Welcome. We are going to go ahead and start Chapter 7. Chapter 7 is describing chemical reactions, is the first section here. You'll find that this chapter probably starts off pretty easy, but it actually is one of the harder chapters in the book. We're going to go through it nice and slow, do a lot of examples. When you get used to it, it's not as bad, but at first, it'll seem like a lot. So let's get started. We'll take it easy here and give you practice problems as we go along. First thing for Chapter 7 is basic concept. Chemical equations represent chemical reactions. So essentially, chemists will use um, chemical equations. So they'll use something like carbon plus oxygen yields carbon dioxide. So we call this whole thing right here, we call this a chemical equation. And it's representing a reaction. Over here, these are what we call our reactants. And this is our product. Now, this only has one product, but there's no reason why you couldn't have more than one product. And many chemical reactions have multiple products. So far, so good. Next concept. Law of conservation of mass says that mass is always conserved in a chemical reaction. So at a general reading of this, what they're saying is that if you've got some reactants and a chemical reaction, and they form some products, the mass of what you put into the system is going to equal the mass of what you get out of the system, what you get out of the reaction. And this will hold true for any regular chemical equation if it's not nuclear based. So the mass of the reactants equals the mass of the products. A lot of times people ask me, they'll say, well, burning is a chemical reaction, and when I burn a paper, it pretty much goes away. There's just a little bit of ash left. Well, a lot of the mass in a combustion reaction turns into a gas or fine particulates. So they might escape if you're not taking special measures to collect them. There are ways to collect the gases from a reaction. But if you were to collect the gases and then find the mass of them, you would still find that mass is conserved. The mass of the reactants equals the mass of the products. Now, even beyond just a general terms of mass, right, another implication of this, let's look at something like carbon, the one we looked at a second ago, plus oxygen yields carbon dioxide, CO2. Another way of applying this law of conservation of mass, let me get a clean slide here so that we have a little bit more room. So if you have carbon plus oxygen yields CO2, another way this applies is that right, you've got carbon and you've got oxygen over here, and you've got one atom of carbon and you've got two atoms of oxygen. Now, what this means is that if you are combining these in this ratio, you need to have the same ratio here. So you have to have the same number of each atom going into the reaction as you have coming out. So again, we have one carbon here, and we have two oxygen here. So this chemical equation is what we would call balanced, because we've looked at it and we've noticed that on each side you have conserved the number of carbon atoms, and you have conserved the number of oxygen atoms. The first tricky thing in this chapter is balancing chemical equations, because they don't always come this way. So let's take an example from the sheet that I gave you yesterday. And this one is CH4, which is methane, plus oxygen yields carbon dioxide and water. Now let's examine this chemical equation, because here we've got on this side in our reactants, we've got 1 carbon, 4 hydrogen, and 2 oxygen. And on this side over here, we've got 1 carbon. So far, so good. We've got 1, 2, 3, right? 2 oxygen here, 1 oxygen here. 3 oxygen, and only 2 hydrogen. All right? So this chemical equation is not balanced. This chemical equation does not follow the conservation of mass. So what we need to do is called balance it. And we balance the chemical equation by playing around with and finding the appropriate ratio of each molecule that combines. So I've drawn some blanks in here. These blanks are the spots that we can change the numbers. Right? And I'll go ahead and I'll give you the solution for this and then we'll walk you through it. Alright, so I've added some numbers in here. And these numbers that I'm adding in here, the 2 here and the 2 here, and the 1, you don't really need to have the 1 here, but I just did that for clarity. These are called coefficients. And so let's go ahead and see how this changes the number of atoms that we have on each side. All right, because before we had, these were the numbers that we had. All right, so this is our unbalanced reaction here. On this side of the equation, we've got 1 carbon, 4 hydrogen, 2 oxygen. Here we've got 1 carbon, 2 hydrogen, 3 oxygen. So if we go ahead and count up what we have now, you'll find that, again, on this side, right, in our reactants, if we look at all of these, we've got 1 carbon, and we have 1 times 4 of these, we've got 4 hydrogen, and we've got, now we have 2 oxygen molecules. So we have 2 oxygen molecules, each one has 2 oxygen, so we have 4 oxygen atoms. And that's in our reactant side. And our product side, we've got 1 carbon. And let's take a look here at our hydrogen. Now we've got 2 hydrogen here, 2 water molecules, and each water molecule has 2 hydrogen in it. So that gives us 4 hydrogen on this side. And we've got oxygen here. Let's count up our oxygen. We've got 1 carbon dioxide, so there's 2 oxygen here. And we've got 2 waters, so there's 2 more oxygen over here, right? Because we've got H2O and then another H2O, so that gives us 2 oxygen. Plus these 2 oxygen gives us 4 oxygen. Right. Now this equation is balanced, and this is the way I would write it. I would write CH4 plus 2O2 yields CO2 plus 2H2O. Right? I don't put the 1s in here. If there's no number here, if there's no coefficient, it's implied that it's 1. So I know you're asking me, well, Mr. Romer, how did you come up with those numbers? How did you know to put 2 there? And some of it is just educated guesses. Honestly, you just have to get used to how you do it. There are some things that you can do that might be a little bit more formal, but for the most part, it's oftentimes just easiest to try different combinations. So I'm writing down the next equation in your book. So the next equation is sodium plus iodine equals sodium iodide. Now, if we do a preliminary count, we see that we have 1 sodium and we have 2 iodine. These are atoms. And over here we do a count. We have 1 sodium, and we only have 1 iodine. All right, so we are not following the law of conservation of mass because this is representing a chemical equation, and we've got, going into the chemical equation, 3 atoms, right? 1 sodium and 2 iodine atoms, but only 1 iodine atom's coming out. So we must do what we call balancing so that we obey the law of conservation of mass. And what draws my eye first is obviously this iodine. This one is smaller. You always have to work up. So in order to get this number to 2, what we're going to have to do is do 2 of these right here. We can only change the number in front of the compound. We can't just add a number over here because that changes what our chemical is. If we add the number over here, we have the same chemical. It's still sodium iodide, but if we do it over here, it's fundamentally a different chemical. So that is not allowed. That's a big no-no. That's what people will try to do oftentimes when they're beginning this. And I guarantee you I will find people trying to do that, and we'll have to reteach them. All right, so you can only add numbers here, and that's what makes it tricky. If you could add a number here, that would be pretty simple and quick, but it's not that simple. So if we add a number 2 here, we're now doubling the iodine, but we're also doubling the sodium. And now we go back over here, we say, oh, look at that. I need more sodium, right? Because now I'm starting with 1 sodium atom and I'm ending up with 2, and that doesn't make sense. So I need to put a 2 in front here. Again, it must be in front. It cannot be down here. That's not allowed. And now I've got 2 sodium atoms at the beginning, 2 at the end, 2 iodine atoms at the beginning, 2 iodine atoms, or 2 iodide ions at the end. This ionic compound, you formed ions. All right, so those are 2 simple examples. I'll walk through, go ahead and try on your sheet, go ahead and try, let's say up through number 7 on your sheet.